Hello, so this video is just going to be a summary of the derivatives of the inverse reciprocal hyperbolic function. So derivatives of the inverse reciprocal hyperbolic functions. So yeah, these functions, sorry, let me write this a bit neater. Hyperbolic functions. So yeah, these functions were ARCOSECH, ARSECH, and ARCOTH. So the first one we did was differentiate the ARCOSECH function, so the inverse cosec function. And the result we got when we did this was -1 over the modulus of x multiplied by the square root of 1 plus x squared. And in terms of the domain of this cosec function and the domain of values in which this derivative is defined for, it's just defined for all x values in the reals apart from 0. So when x equals 0, we don't have a defined result. So our cosec of x is not defined at 0. But for all other x values, this is actually defined. And again, that's basically because the cosec function is not defined at 0, but it's defined for all other x values. So that's why we have that domain. And then if we go to the next one that we did, so we differentiated the ARSECH function of x. And when we did this, the result we got was very similar. So +1 over the modulus of x, but this time the square root of 1 minus x squared. And this result was actually valid for all x numbers between 0 and 1. So x had to be strictly between 0 and 1 for this result to hold true. And again, that's kind of because of the sech function. So the sech function, like what we sketched in the previous video, so sech kind of looks like this. Let me try and do that again. So something like that, roughly. You've got 1 up there, a maximum point of 1. You can clearly see that this sech graph, so y equals sech of x, let's just make that clear. It's obviously an even function. And I mean, we can't have an inverse of an even function defined. So we have to restrict the domain. So what we did was restrict the domain between 0 and positive infinity. So this domain there. And then when we take the inverse of that, so just reflect it in the line y equals x, we get something that looks like this instead. So we got for y equals r, sorry, not arc, it should be ARSECH of x. So we got something kind of looking like this instead. So starting at 1 and tending to infinity as x tends to 0 from the positive real axis. So we can clearly see the domain is between 0 and 1. So the derivative is valid between 0 and 1. And obviously, if x were to be equal to 1, then the derivative is not going to be defined because, as we can see, 1 squared is 1, 1 take away 1 is 0, square root of 0 is 0, 1 divided by 0 doesn't exist. So that's why our domain of x values is between 0 and 1, not including 0 and 1. And then the third derivative we did was this ARCOTH function, so the inverse cotangent hyperbolic function. And then when we did this, we got 1 over 1 minus x squared. And this result was valid for all x numbers with a modulus greater than 1. And just some points from here to note. So what we noted in the previous videos when we differentiated these functions was we noted that ARCOSECH of x is exactly the same as the ARSECH of x, sorry, ARSECH of 1 over x function for all x values in their domain. We also noted that the ARSECH function again is equal to just the ARCOSECH of 1 over x function for all x values in the domain. And also what we found was the ARCOTH function, the ARCOTH function, is equal to the R-tanh function when we evaluate it at 1 over x, like so. So again, and valid for all x values in that function's domain. So we know that when we differentiated these functions here, we got the same result as these functions here, because we showed that these functions were all the same. And another interesting thing that we noted was that the derivative of the ARCOTH function, so that gets you the same function as when we differentiated the R-tanh function. So we noted that, yes, we noted that the derivative of the R-tanh function gave us the same result as the ARCOTH function, but the R-tanh function is defined for x values which have a modulus less than 1, whereas the ARCOTH function is defined for x values with a modulus greater than 1, as we can see there. So something that we made note of in that video, let me just rub this out here. So something we made clear is that when you actually integrate this 1 over 1 minus x squared function, so when you integrate this, it depends what part of the domain of x values you're working with. So if the modulus of x is less than 1, then the result we got was R-tanh, so R-tanh of x, if the modulus of x is less than 1. Well, technically, I should put a plus c there. And also, if the modulus of x is greater than 1, then the result we get is this ARCOTH of x function. Again, plus a c, and that's if the modulus of x is greater than 1. And obviously, if the modulus of x is equal to 1, then this function there is undefined. So yeah, that's something we did in that previous video. But yeah, so in summary then, the key results here were these 3 results here. So yeah, when you differentiate these 3 functions, you get the 3 results as shown below.